Hi everyone. Okay, here's our topic for this part of the lesson, durability and shock absorption. So looking at material testing again. So can you do date title keywords and answer the do now questions while the video is paused? Moving on to the do now questions then. Why do we make alloys? Hopefully you've written down that we make alloys to improve the properties of metals. So it's usually to make them stronger. So an alloy is a mixture of a metal with another element, which could be a metal or something else. Often carbon is used in alloys of metals. What's a composite? Well, a composite is a material made by combining two other materials together, and that gives us the properties of both materials in our new material. And graphene is one of the fullerenes. It is a, not a fullerene, it's an allotrope of carbon. It's like graphite, but it is a single layer of carbon atoms bonded together. It's extremely strong despite only being a layer 1 atom thick. Okay, let's talk about durability. So in science terms, here's a long definition: the ability of a product to perform its required function over a lengthy period under normal conditions of use without excessive expenditure on maintenance or repair. You might want to pause the video and jot that down. But in everyday language, if a product is durable, it means that it lasts. It lasts a long time despite being used regularly to do its job, and doesn't require early replacement or repair or maintenance in a time that you wouldn't expect. So it does its job and it lasts. That's what we mean by durable. We're now going to look at a video made by the car manufacturing company Ford, showing us how they test the fabrics that are used inside the car for durability. Make notes on these as we go, because you are going to have a mind map task to do later in the lesson using your notes.
Materials for the vehicle is essential in order to achieve the desired durability and performance outcomes for the components. There are many examples where the customer comes in contact with a hard trim with either their nails, rings, or jewelry, which can scratch the plastic. So we have a test that we call the 5-finger scratch test. 5 pointed fingers apply different levels of force to a pointed scratcher, and we can get a direct measurement of how much force is required to scratch the components. Customers tend to put a lot of force on the fabric of the seat. For the stretch durability test, we basically stretch the fabric to ensure that it meets our quality requirements for upholstery and trim. This makes sure that the seat covers don't become stretched and loose over time. We have a test called the mace snagging test, which is representative of any sharp objects the customer may have in the vehicle. The spikes impact the fabric, as well as being dragged across it, to ensure that the fabric doesn't get damaged by scissors, keys, pens, or any type of sharp object that could damage the fabric. When a customer sits on the car seat, there's a potential for the fabrics that customers are wearing to transfer dye or stain the seat. So we have the Martindale resistance test to measure whether the fabrics are susceptible to dye transfer from materials like denim. Things like greases, mud, suntan lotion, coffee, and even perspiration all have an impact on material components. The stain resistance test is an important test because not only will the customer be upset if the stain can't be removed, but it can also have a significant effect on the resale value of the vehicle. The most commonly used stain resistance test is the cleanability test. We introduce the contaminant onto the fabric, which could be grease, synthetic soil, or coffee. and then we follow a specific cleaning procedure to attempt to remove the stain. We evaluate the stain before and after the cleaning procedure to ensure that the stain can be acceptably removed. Selecting the right materials for the vehicle is essential in order to achieve the desired durability and performance outcomes for the components. There are over 100 different materials that go into the interior of the vehicle that affect the overall odor perception of the vehicle. The difficulty when it comes to interior odor is that everybody's a little different. Some customers like the smell of leather, while other customers hate the smell of leather. So within Ford, we do a significant amount of odor testing to ensure that we satisfy the greatest number of customers. In the odor test, we actually take a sample of the material and put it in a glass jar. Then we emulate common climate conditions inside the jar, like humidity or the high heat of a car that's parked out in the sun. Once the materials are warmed to the appropriate temperature, we have a panel of approved odor assessors that come in and evaluate the smell. The overall goal is to reduce the overall odor in the vehicle as much as possible in order to make sure that the quality of our vehicles is as high as possible.
Okay, so as you can see, it's not just things like strength that manufacturers have to test for. I thought the odor test was really interesting. I remember my dad years and years and years ago when I was a kid worked for a company where every couple of years he'd get a new company car. It wasn't a particularly pucker car, but he had to take clients out, so he had to have a clean car. And every couple of years he'd get a new car, and the smell was absolutely disgusting to me. The fabric and the glues in these new cars smelled of fish, and I can remember just feeling physically sick for the first sort of month of him having a new car every time I got in it. Revolting. Right, shock absorption testing. We've already, in the previous part of the lesson, seen the video on sports helmets, so I won't show you that again, but I'm going to show you this video on shock absorption in shoes, because when you run, for example, it's really, really important. If you're running long distances regularly, that puts huge forces and shock through your joints. So having material in your shoes that absorbs the shock, that is the impact on your body, is really, really helpful in preventing things like joint problems. So this is a very simple test, similar to what we've seen before, that shows how different two materials can be in absorbing shock in an insole. Oh, there we go.
Okay, here's test number 3. Here's another insole, the bottom of it. Okay. And we'll take a test insole. Okay, here we go. 1, 2, 3. Okay, as you can see, one on the right claims to absorb shock. Actually, the ball bounced about 6 inches in the air. The nanosop bounced about a quarter inch.
So in that test, the ball is obviously representing your foot as you're running, and it's the impact of your foot on the sole. So on the right hand one, the ball bounced, which means that the ball, i.e. your body, was retaining the energy from the impact, whereas the one on the left hand side, the insole, absorbed that impact, so that would cause much less stress on your ankles, knees and hips. Okay, before your main task, we're just going to do some true or false questions to just help you recap what we've done over these lessons. So the video can be paused. Just have a look through those sentences. You can just jot down whether you think each one is true or false, and then I'll show you the answers. So pause the video now I'm going to move on to the answers now. She says, there we go. Okay, so green are true. Red are false. So just to clarify some that you may have struggled with. Number 2, the more shock a material can absorb, the more damage it can cause on our joints. It's the opposite. The more the material absorbs, the less damage on our joints. Tensile, sorry, that's a true one. Stress can be defined as pressure or tension. Stress can be defined as pressure, but not tension. That's why that one's false. Number 6 might be true, but isn't necessarily true. Number 11, stress depends on friction and area. Well, stress depends on force and area, and friction is an example of a force, but there are other forces too. So stress depends on force and area, not friction. And I've just remembered number 12. You may not have covered that yet. So if you haven't done, if we haven't done Hooke's law, you won't know that one yet. Sorry, I should have taken that one out. Okay, moving on to your task. So you're going to make a mind map now about the various tests and properties we've been learning about. So I've given you some suggestions on the screen of things you could include. This is, I don't mind how you lay it out. This is a memory aid. If you prefer actually to make notes in colours rather than do a mind map, that's fine. But what I want is something that you've got that you can look back on, use as a revision resource to remind you of the different tests that are carried out, what properties they're looking for when they carry out those tests, and also the types of materials they would do and functions of materials they would use those tests for. Okay, so you've got the rest of the lesson to complete that. The video can be paused so that that is on the screen for you.